Yeah, that's it.
Okay, good morning everybody. I will talk about a problem that we were addressing on IRSC2012 using the wind forecast information that we have now available for very accurately for a short range of time, let's say 1 day, 2 days. We can actually trust very well in the information about the weather forecast or wind forecast. And the problem is how can we scan a region on the sea with a sailboat, because the sailboat has constraints that are not applied to motorboat because of the wind, of course. And well, under steady wind, if we have wind stable and with the same direction, the same velocity, the best solution is to go to a waypoint upwind. For example, look at this scheme here. If the wind comes from the north, from the top, to start the scan of this area with parallel lines, we should go to a point upwind and then navigate with along lines that are perpendicular to the wind direction. And this is the best solution because it will give the best speed for the boat, usually for normal sailboats. In this situation, we will have similar speeds on the left to right and right to left legs. And this is good because it will take the same rate for example, acquisition of data from the sea or from any parameter that the boat is going to acquire from the environment. And is also the best course to compensate for the leeway, because you can go slightly upwind to compensate the natural leeway of the boat. The problem, and this is, well, I think everyone that sails agree with this solution. This is the best for when the wind is stable, when the wind does not vary during the mission. But the problem is if the wind, especially the wind direction, changes during the mission, it is impossible in the general case to maintain such scan pattern. And the problem is, if we choose one initial direction or scan line direction for the initial wind direction, during the variation of the wind direction, we will have not the same boat speed between different flags, because we will have different apparent wind angle with the boat. And if we observe large wind shifts, large wind direction variations, that can also invalidate the navigation plan, because the boat may enter the forbidden angle and could not navigate in some cases. Well, the solution that we propose, actually we didn't conclude this study and this work, and this is just a proposal that I would like to discuss with you and listen from the suggestions from the audience, is to divide the scan area in sub-scanned regions, okay, and scan each region with parallel lines, just more or less as the first picture. And the problem is, how can we exploit the wind forecast, the short-term wind forecast for 1 day, 2 days, 3 days, that we know that are more or less accurate, and of course can be updated in real time to adjust the forecast. And the idea is given the wind forecast, especially wind direction forecast, select time intervals where the wind direction varies within a certain interval, within a certain limit. For each time interval, define a parallel line scan pattern, do that scan pattern, and then when the wind direction varies more than a certain value, mark that region as a done scan, and then re-enter the scan procedure for a different region that was not scanned before. Well, of course, we can accept a small variation from the ideal 90 degrees angle from the true wind, and using this information we can set up a procedure that is like this. Okay, imagine that the wind direction, this is no scale, but we can imagine that time scale is tens of hours. Wind direction maybe is degrees, of course, but in this scale we can imagine this interval maybe tens of degrees. and imagine the wind direction varies like this chart, okay? The idea is, first we divide the timeline in slots, in time slots, for which the wind direction is predicted not to vary too much, okay? And this too much is one optimization parameter, okay? If we move this line to the right, of course, this variation of the wind direction will increase, okay? And that will affect, for example, the speed of the boat between the left to right leg and the right to left leg. So we can divide this in time intervals that have different durations. And then, for the first time interval, we set up a scanline navigation pattern like this. Okay, we start in the upwind point. We can either start on the right or on the left, and this will affect the transition for the next area scan. Start scanning this area with a navigation more or less perpendicular to the wind direction, okay? And when this time, when we get to this time position, we have concluded this scan line, and the procedure will ignore this last uncompleted scan line and mark the region on the top as done region, redefine this new scan region, and go to a different scan region using the information, the redirection for the next interval. Okay, this is not at scale, and during the second interval, okay, this is not scale, so the difference of wind angle between this region, that region will not be similar for that, just to show you an idea. But at the end of this time, we will shift to this new scan pattern, starting on the end of the last scan pattern, okay? So we have to navigate, again, upwind, the new wind. Of course, the wind does not change suddenly, but we can define a threshold of the wind direction when to decide to go to a different wind path, to a different scan pattern for a different wind, okay, for a different wind direction. Well, this of course is a cost, okay? If we stop here, we need to navigate slightly upwind to restart the new scan pattern. But for example, if we start not at this point, if we start at this point, we'll navigate from left to right, then right to left, left to right, okay? And because we know the wind forecast, we can predict then, sometime after, we will need to stop this scan pattern and go to this scan pattern. And then we can stop here, okay, and the cost of stopping here and go to an upwind point to the next pattern will be less than in this situation that is shown in this picture. Okay? Then the third interval, something like this happened. We stop this scan at this time somewhere in this position. Then we have to navigate, the wind will come from this direction. Okay, we have to navigate to the upwind point and restart the scan pattern. Okay, possible, this is generally speaking the procedure to create sub-regions, scan patterns with parallel lines. And possible optimizations can be the total mission time, the total time that it takes to complete the scan of the area. Minimize the speed difference between legs in one direction and in the other direction. Minimize the number of non-scan legs to reposition the boat for the next scan area. Minimize the number of maneuvers. For example, if we need to adjust the sail or if we need to change course very often, we will waste more power. Or can be also to minimize the number of subscan regions. Actually, I don't have any strong argument for this optimization criteria, but it's a possibility that can be considered this. The tuning parameters, where we can change the procedure to tune to get different objectives, different results. For example, to define different starting points for each subscan. Okay, basically we can, for each scan line pattern, we can start at right or at left, and that will impact on the next point will be to start the next area. The maximum wind direction variation during a scan. we can, ideally, the boat will move best if the true wind comes from 90 degrees, but of course if it comes from 70 to 120 degrees, that may be acceptable. It depends on the type of the boat. Okay? And the initial true wind angle could be initially, we could define the scan lines perpendicular to the wind at the true wind direction at that point, but we can define an angle slightly less than 90 degrees or more than 90 degrees depending on the trend and the variation of the wind direction. Okay, to account for the wind direction in the future for the same scan pattern. Okay, so this is the idea. This is we don't have any solution for this. Okay, actually, I have made some simulation in MATLAB. I don't have the results here, but with this presentation, I'd like to present the idea, to discuss with you, and to hear from you suggestions and comments and questions. Okay, thank you.
Thank you. If you have a question, yes.
A key question in your approach is how much credit do you assign to the forecast? Because that is it's a problem.
Well, from my experience, the weather for at least where we sail in Portugal, also Portugal, the wind forecast for 1 day, for 1.5 days is quite accurate. Okay, of course, it's not the right wind that we'll have in the future. Okay, but this procedure can be adjusted in real time. Okay, and of course, the ideal solution will be to make some plan for 1 day or 2 days or some tens of hours. But of course, you can do that for a small time span. Okay, where you can have a very accurate wind forecast. Okay, and then adjust a bit later for the new forecast. Okay. But of course, that's a problem. The question is it worth to do all this work or to do this type of planning based on the wind forecast, or is it better to do this in real time with the current wind data we have? Okay, and the very short-term forecast. I don't know, 1 hour, 2 hours or so. And but my question is that may depend on the scenario you need to scan. Okay, if you need to scan one area by tens of miles, maybe we need some planning, previous planning to do that. Okay.
Sorry.
First of all,
Yeah.
Let's see. Go.
okay.
Well,
So I think it's a very, very important discussion and topic towards applications with robotic sailing boats. One question is it when the wind direction shifts a lot, varies a lot, is it then possible with this algorithm that there remain several unscanned areas which are not linked together, and you have in the end long ways to cover all regions?
actually, if the wind, I'm not sure either, but if the wind changes, the wind direction changes smoothly, and this is usually the case, not exactly the case, sometimes it stops and starts from very different direction. But that will not happen, I think. Because
and if you have non-convex shape,
okay, that's a different problem.
Yeah,
Okay,
that's
with a
the-
non-convex shape, okay,
Yeah.
this assumes a convex shape like this. Okay, of course, if you have a non-convex shape, you can divide it into a group of
Several
convex shapes
convex,
and
yeah.
decide a different scan. Okay.
So last question.
Actually, it seems that there are discontinuities in the time, because you may end at some point, like recording, go to another point, record there, come back to the first point, and so that leads to the larger question: do we actually have an idea where we would have a pattern like that? Like, is anybody requesting us to do something? Because all the optimization you outlined looks very interesting to me. But the real question is, what is the application like? Is it important that we have the same speed? Is it important that we do it in a continuous manner, that we record everything in a line fashion? Where are the applications?
Yeah, in some cases it is important to have a scan of a region with parallel scan lines. For example, if you are using sonars to get information from the bottom, and maybe Nuno can answer this better than me. Can you?
Yeah, yes. If you are, for example, in military application, if you're looking for mines, for example, or if you are making a survey of the bottom for geolocation or something, you really need to have a certain spacing between lines, so you are sure that you get the full coverage. So you don't really matter how much time you take to get that information, providing you have an overlap between the two lines and you have constant. So it's not a question of time, it's just a question of geographic coverage. And from that scenario, you want to make sure, sometimes you even overlap to make sure that you don't lose anything.
So it's kind of the scenario you're looking here primarily.
Of course, you can do something random. Okay? Put the boat in, let's say, station keeping in that area, okay, and let it recording data, whatever you want to record, and hope that it will cover that area at the end of some time. You have no guarantee that you will.
Okay. So,
Any more questions? Yeah.
the last question.
Yep, I'll try to be quick. I really like this and see this as a key step in our ability to use this for oceanographic research. A suggestion, I know that the British Coast Guard and the American Coast Guard did a large study on different search patterns and which ones cover the ground fastest. And they include an effect for wind shifts. And they looked at two ways. One was an oscillating wind shift at sort of 15 to 30 minutes, which you might be able to discount on a large scale but not small scale. And then the other is a persistent shift due to a frontal passage. So that would be my suggestion to look into their research. A question I would have for you is, would you see a difference between if you say started your search pattern upwind and worked your way downwind, or if you started your pattern downwind against the waves, for instance, and worked your way upwind?
Who wants to navigate upwind? I prefer to navigate downwind than upwind. I think, well, actually I didn't think about that because I think the best is to, well, navigate upwind is much more complicated, much more subject to the leeway of the boat, to currents, and downwind is faster, it is easy to control. Do you have any good reason to navigate upwind, or?
Or maybe your starting position is downwind. Then you don't need to go upwind first.
Yeah, but you can take the boat upwind and drop the boat upwind. And of course, you can, while you go upwind to start the mission, okay, you can start recording somewhere. But doing something like this with upwind navigation, we'll have to navigate upwind to go from this scan line to that scan line.
Yeah.
Okay, that will take more time for sure than going downwind.
Okay, thank you.